Today, we're diving into something that, believe it or not, affects all of us every single day: our power grids. We're going to look at how a brand new AI is completely flipping the script on how we forecast our energy future. But first, let's just kick off with the big question, right? Can AI actually predict the future with perfect accuracy? You know, it sounds like something straight out of a movie, but as we're about to see, one new model is getting scary close.
All right, let's get into it. Before we talk about the cool new solution, we really need to understand the problem. And trust me, it's a massive one. Our entire power grid is basically running on what you could call a huge, high-stakes gamble, 24/7.
Yeah, every single second of the day, grid operators are on this tightrope. It's a crazy balancing act. They have to predict really, exactly how much electricity millions of us are going to use. If they generate too little, you get blackouts. But if they generate too much, all that energy and all those resources just go to waste. The margin for error here is razor thin.
And that balancing act, it's getting tougher all the time. Our industries keep growing, millions of us are plugging in electric cars, and we're relying more and more on renewables like wind and solar. And you know what? The sun doesn't always shine, and the wind doesn't always blow. All of this just throws more chaos into the mix, making an accurate forecast more important than ever.
So, faced with a problem this big, this complicated, what do you do? Well, a team of researchers came up with a pretty amazing answer. It's time to meet FARHAN.
So, what in the world is FARHAN? Well, at its core, it's a cutting-edge, hybrid AI model. And that word hybrid is the key. This isn't just one AI doing the work. Nope. It's a whole team of different neural networks, all working together in a sequence to come up with these incredibly precise forecasts for our power grid.
And what I love about this is it shows you exactly where FARHAN lives in the whole world of AI. So picture artificial intelligence as this huge outer circle, okay? Inside that, you've got machine learning. Go a little deeper, and you find neural networks and deep learning. These are the really complex systems modeled after the connections in our own brains. That is the super advanced playground where FARHAN operates.
Okay, so we know what it is, but how does this thing actually pull it off? Let's pop the hood and take a peek inside the prediction engine. Whoa, okay, at first glance, I know, this looks insanely complicated. Because it is. This is the whole shebang, the complete map of how FARHAN works, from raw data coming in one end to the final prediction coming out the other. But don't worry, we can actually break this whole thing down into 4 pretty simple steps.
Here's the breakdown. First, an AI block called an LSTM, which is amazing at finding patterns over time, takes a first crack at the data. Think of it as a first draft. Second, that result gets cleaned up by what's called a 90% gain averager. It's like a smart filter that gets rid of the noise. Third, a second AI block comes in and analyzes this cleaner data, digging even deeper for hidden patterns. And finally, a different kind of model, a Markov model, does one last check. It's like an expert odds maker calculating the most likely outcome, giving us that final, super accurate result. It's this brilliant multi-step process where each stage makes the prediction better and better.
So, all that work, all that complexity, did it pay off? Oh yeah. Let's get to the good part and look at the truly stunning results. Get this. The model achieved what's called an R-squared score of 1. Now, for anyone who knows statistics, a score of 1 is basically the holy grail. It means the model's predictions were a perfect match for what happened in the real world. It's literally a perfect score. And if you want to see just how precise it is, look at this number. The error rate was just 0.019%. I mean, that's an unbelievably small error. And this wasn't on some short, easy test. No, this was its accuracy over a massive 14-year-long set of data. Incredible. And if you need to see it to believe it, this slide says it all. Look on the left. You see FARHAN's prediction, the red line, hugging the actual data in blue so closely you can barely tell them apart. Now, look to the right. That's a normal, pretty good AI model, and you can clearly see that gap between what it predicted and what really happened. The visual evidence here is just undeniable. And the hard numbers just drive the point home. This table puts it in black and white. If you look at the root mean square percentage error, FARHAN is sitting at 2.5%. The standard model, 6.3%. That's more than double the error. FARHAN isn't just a little better, it's playing in a completely different league. Look, this is all incredibly impressive stuff if you're an engineer or a data scientist. But let's bring it back down to earth. Why does this actually matter to you and me?
Because this kind of super smart forecasting has huge real-world benefits. It means a power grid that's way more stable and reliable, fewer blackouts. When we can predict our energy needs this perfectly, we stop wasting so much fuel and so many resources. And this is a big one. It makes it so much easier to plug renewables like wind and solar into the grid. It all leads to smarter cities, lower costs for us, and ultimately, a greener planet.
You know, the researchers who built it summed it up perfectly. They said FARHAN's approach establishes it as a robust and intelligent tool, promising significant advancements. This isn't just a small step forward, it's a giant leap in what we're able to do.
And that brings us right back to the future. With this kind of pinpoint accuracy, our power grids feel like they're just the beginning. It really makes you wonder, right? What other huge, complex system will an AI like this learn to master next?